This is a more difficult example. Perhaps it also brings up the notion of why do we complete the square? It's obviously more difficult, more nuanced, but yet it's going to help us later on. We only know how to solve an equation, a quadratic equation, if it's factorable. Notice 3x squared plus 6x plus 1 is equal to 0. The left-hand side is not factorable. So you cannot solve this equation by factoring. So you need a new method, and that new method is completing the square. Recall what we're going to do, though. Our final goal is to create, or a great intermediate step is to create a perfect square factor on one side and a constant on the other. We do this by completing the square. So we need to remember the rules of completing the square. That is, we need to make the coefficient in front of the x squared 1, and we need to have the constant over on the other side, variables on one side. I'm going to divide both sides of the equation by 3. Love dividing 0 by 3 because it's 0. The next step I'm going to do, so I'm just going to divide both sides by 3. If you want, you can see divide both sides by a. The next thing I'm going to do is I'm going to add the constant over to the other side. So, I'm going to subtract negative 1/3. Sorry, I'm going to subtract 1/3 to both sides. The next thing I'm going to do is I'm going to complete the square. I'm going to add 1 to both sides. So I'm adding 1 to both sides to complete the square. Now y1, took this middle term 2, divided it by 2, which is 1, and I squared 1 is 1. So that's why I added 1. And now I'm going to factor the left-hand side, which is x plus 1 squared. And on the right-hand side, I'm going to add them. So really, this is just negative 1/3 plus 3/3, and we have 2/3. So there's my perfect squared factor and a constant. The next thing I'm going to do is I'm going to take the square root of both sides. Done. Now notice that we're starting to enter a stage of uncomfortableness because we are dealing with irrational number on the right side. The square root of 2/3 is irrational. You can't simplify it. So I'm going to subtract 1 from both sides. And this is done. Well, it is done, but it does not meet sort of math conventions. Math conventions really want everything under a common denominator. Not only that, but the denominator cannot be an irrational number. So really, I'm going to try and write this as follows. I need to make my denominator rational. For instance, now I'm going to split up the square root as the square root of 2 over the square root of 3. Now, how could I make this denominator a rational number? That is, a whole number. Well, I'm going to multiply this by root 3 over 3. And when I do that, I get root 3 over 3. My denominator is just simply 3. Root 3 over 3 squared is 3. Now, root 2 times root 3 in the numerator is going to be root 6. Now, I'm almost done. I'm going to put this over a common denominator of 3. So my 1, I'm going to write it as 3 over 3. over root 6 over 3. So really, this is going to be 3 plus or minus root 6 over 3. Now, let me go over this because I think I see an error. So I'm going through here. This is all good. And then what I should have put here is I subtract 1 from both sides. And I'm done. Forgot my latest plus minus. You may be asking, why is root 2 times root 3 equal to root 6? Well, this follows the exponent laws. If we have a to the power of n times b to the power of n, this is just really the product of ab all to the power of n. And here our exponent is 1/2 because we're taking the square root.